do 8. We'll do 8 together here. This problem is an end behavior problem. And when you see end behavior, oh gosh, and I've got to try to write with my mouse, so it's not going to be good today. There. So when I have end behavior, I should be thinking the limit as x approaches negative infinity of f of x. Or it could be the limit as x approaches positive infinity of f of x. Here. So, what do I have to do those limits at the end, that end behavior? Particularly for 8. Let's say for 8. I'll look at my exponents, right? Highest degree exponent is what's going to matter. For 7, I would need to know what that was. Now, 7, I could really kind of do this without expanding it completely. Because I'm raising this to the 4th power, and this is just a negative x right here, right? So that very last term is going to be negative x to the 4th power. And then I'm going to have to distribute the 3x squared to it. So I'm not doing the whole thing. I'm just thinking about what's going to happen here. So that's going to be, this is going to be a positive x to the 4th. So I would get 3x to the 6th power. That would be my highest term. So I may not have to like actually expand the whole thing. I can think about what Pascal's triangle is going to look like. The highest term is going to be whatever that last term is, which would be that negative x to the 4th. And then I've got this out here that has to be distributed. So if I've got a positive coefficient, I would get a positive on the right side. That right side would go up. Yes? Whenever you raise a negative to the 4th power, it's going to become a positive. Because when you do negative times negative, we get a positive. Then negative again will turn back negative, but the last negative will make it back positive.
So why do you keep the 4 there if you're doing that? Like, doesn't the 4 go away if you do that?
You are raising both of these things in that parentheses to the 4th power.
Oh.
So negative to the 4th is like a positive 1. It kind of goes away, but you still have x to the 4th power there. And then since this side goes up and I have an even exponent for that highest exponent, I would also go up on the other side. So I would get positive infinity for both of these. For a problem like 8, we again need to just need to know about those highest exponents, right? So when I expand this, I could fully expand it, right? I could use Pascal's triangle and fully expand it. But the only one that's going to really matter for the top is going to be that first term, right? So whenever I look at it, it's going to be x to the 3rd power, right? And then it will have other stuff, but that stuff won't really matter because it's not going to be the highest term, right? So whenever I'm doing limit as x approaches infinity, or it could be negative infinity. There, in the top, I'm going to have an x to the 3rd power. In the bottom, the negative 2x is going to be our highest. So you're going to have some other stuff at the beginning, but the last term is going to be negative 2x squared. And so that's the term that's going to matter there. Let's see, I need the eraser. I still have the parentheses, so not yet, but it is going to on the next step, yes. I don't want to do that. I get to the stinking eraser? Okay, apparently I don't have an eraser that I can get to. So we'll be doing the limit as x approaches infinity of x to the third plus some stuff that we don't care about because it's not the highest exponent over, on the bottom we'll have some stuff we don't care about because it's not the highest term, and then we'll have 4x squared. And so that's a 3 right there, even though it's hard to tell because I'm writing with my mouse. So if I divide, first of all, if limit x approaches infinity, we are doing no ECC. This one is bigger on the top. That means there's not a limit. It's either going to be positive infinity or negative infinity. To decide, we're going to divide these. So we'll have 1x cubed over 4x squared. And so the 1/4 does not reduce. That stays as it is. I got 3 x's on top, 2 on bottom, so I just get an x right here that has an exponent of 1. You don't have to write it, but it's there. So my coefficient is positive. That tells me my right side is going to go up. And then my exponent is odd. So that tells me the left side is going to be the opposite. So my limit as x approaches negative infinity of f of x is going to equal negative infinity. And my limit as x approaches positive infinity of f of x will equal positive infinity. It certainly works just to like expand the whole thing out. If you want, you just don't have to do the whole thing. So you may see some of these things where Pascal's triangle can come in handy for doing that, even though you don't have to do like the whole thing. I'm going to skip that. I can't remember why I put it there. But we've already factored some, so I think we can skip that. Alright, so slant asymptotes. There's only going to be one scenario where your graph is going to have a slant asymptote. So, when the degree of the numerator is exactly this is painfully slow. 1 greater than the degree of the denominator, the function has a slant asymptote. To find that slant asymptote, we have to use long division to rewrite the equation in a different form for that. So, the slant asymptote, you can see like this equation right here, it has a vertical asymptote, but then it also has this like slant asymptote here where that you've got a slanted line that the graph gets closer and closer and closer to. Now, its end behavior is still like positive infinity or negative infinity. You don't have like a horizontal asymptote there. But we can find the equation of this line right here. So, let's look at what we have to do for that. So for this, we are going to have to do long division. And it is going to take me forever to try to write this. I think I'm just going to write on the board. That is not going to be particularly helpful for the ones at the house.